Welcome to qnawire.
Hi, so in this case we're going to have a solution made out by mixing zero point 0.1 liters, zero point 0.1 liters of each zero point 0.2 molar acetic acid that I'm going to abbreviate as HAC, just to make it clear that it's the acid, with the same volume of zero point 0.5 molar acetate. Hmm. That means that the amount of mole that we added for each of them for the acetic acid, remembering that the definition of molarity is amount of mole divided by volume, so amount of mole would be molarity times volume. The amount of mole that we added of acetic acid will be equal to zero point 0.2 molar times zero point 0.1 liters, which would be 0.02 mole of acetic acid, and the amount of mole that we added of the acetate in our solution coming from the sodium acetate will be similarly 0.05 mole of acetate. And we're asked what is the pH of the buffer that we're going to get. Well, first of all, we can calculate directly the concentrations of AC minus and the concentration of HAC because since we're going to have a buffer, we're going to employ the Henderson-Hasselbalch equation. But as you can see, if we apply the definition for molarity, you're going to see that just in this case, when we are dealing with buffers, we can cancel out the total volumes, and we can use directly the amount of mole that we get of each of them. Regardless, if we do the calculation for AC minus and for HAC, recall that the concentration would be the amount of mole. AC minus is 0.05 mole divided by the total volume. We mixed 0. 0.1 liters of each of the solutions, so assuming that volumes are additive, divided by 0.2. And in the case of acetic acid, 0.2 mole added to 0.05, sorry, divided by 0.2 liters. Divided by 0.2 liters. So the concentrations for each of them would be 0.25 molar and 0.1 molar, correspondingly. As you can see, the result it is not going to change much. If you do the division of the amount of mole and then you do the division of the concentrations, you're going to see that the result will be exactly the same. So in order to get the pH of this buffer, as I said, we're going to employ Henderson-Hasselbalch equation. pH is equal to pKa plus logarithm of concentration of the conjugate base, that is the acetate, divided by the concentration of the weak acid, that is the acetic acid. The pKa for acetic acid turns out to be 4.76. So this value you can look it up in tables. Plus logarithm. Here I'm going to use the concentrations just for sticking completely to the definition, but as I showed you, the result is going to be the same. And after doing this operation, we find that the pH will be equal to 5.18. Sorry, 5.16. So that is the answer for part A. Now, in part B, we are going to assume that there's no volume change, but we're going to add 0.01 mole of HCl. Recall that HCl, when it goes into contact with water, H2O, it is going to produce the hydronium ion plus Cl minus. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. So the amount of mole that I added of HCl, it is going to be equal to 0.1 moles of H3O plus. So for this reason is why I calculated at the very beginning the amount of mole that I had of acetic acid and of acetate. In this case, the reaction would be the conjugate base with the acid. It is going to produce acetic acid plus water. And we're going to do our ice table in terms of amount of mole. Of AC minus of the acetate, I had initially 0.05 mole. I added 0.01 moles of hydronium ion, and of acetic acid, I had initially 0.02 mole. The amount of change is given by the limiting reagent, that is the acid in our case. So I subtract in the reactants, add it up in the products. I'm going to get at equilibrium 0.04, 0.03. Perfect. And remember that this is the amount of mole of AC minus, and this is the amount of mole of acetic acid. So right now I'm going to use this fact over here in order to calculate my pH with the Henderson-Hasselbalch equation. So the pH will be equal to the pKa, that is 4.76, the value that we found here from our tables, 4.76 plus the logarithm. Instead of using the concentrations, I can use the amount of mole. So this is 0.04 divided by 0.03. The result of this is a pH equal to 4.88, or approximately 4.9, depending on the resolution of the instrument that you have. So now let's compare the results. We initially had a pH of 5.16, then I added a certain amount of acid, so I expect the pH to decrease. And the result makes sense. We can observe that, and that in that way we can verify that everything went according to plan. And that would be all. Thank you very much.